Thank you.
All right. I'll just reiterate that for the folks that are on the line or for the recording. So joining me today, not just myself, but I have my colleague Tony James. And then immediately after this topic, we have a couple more red hatters that'll take a deeper dive into some topic that we will cover during our discussion. And actually, our last presentation there, some of the discussion points immediately transition to kind of the topics that we're talking about, particularly around containers. And what we want to do is kind of break the ice around the idea of containers as kind of the preferred packaging format and delivery format for all sorts of applications, up to including safety critical applications. And some of this comes that is driven by our work in the automotive space. And you probably heard some of our colleagues talking about that either yesterday or during their kind of discussions around building an operating system for in-vehicle use and those safety critical applications that are used there. Tony, next slide. And really, we're going to kind of hit this from one specific angle, which is the idea of packaging your entire operating system as a container. And really, it comes down to the question of, like, right now we use containers, and containers have really taken over the enterprise software world because they provide a lot of inherent advantages. It's a compact packaging format. It's self-describing. It has things like cryptographic attestations, content identification. Its architecture using what we would call layers is very composable. It allows us to
Looks
All right.
on my side.
I will see if we can fix the
Back.
slides here. real quick.
Oh, that's odd. That's strange. It's probably a Wayland issue.
It does actually look like a sidebar.
It was fine.
Yeah, that's not.
Yeah, it was okay.
Oh, really? As soon as I hit that hide thing, it went away?
Yep.
Or popped up?
You want out on prompt, can you? There you go.
All right. All right, match it. We, turn it off and on again and everything works. All right. So containers, we've seen them taking over this enterprise space because they solve a lot of specific issues. Well, those same issues arise not just in that enterprise space or in-vehicle operating system space, but also in the space domain. And the real question is, well, they solve all these problems in these domains. Why can't we do that for our entire operating system and the space domain as well? Sure. So ideally, you want to take that same technology, use it for our operating system. And the whole idea here is and we talked about reuse several times already. It's like a recurring theme. Reuse, because that reuse paradigm makes it a lot easier, especially to repackage or reuse software, applications, operating systems, but also to verify and to assert properties about those different components. And the nice thing about containers is because they are these self-contained packages that contain all that metadata, contain all the dependencies, all the files that you need. It's very easy to reproduce those. It's very easy to take that same package and move it wherever you want, and do that regardless of what you're doing or using that container package structure for. So applications, operating systems have the exact same sort of workflow for building, maintaining, patching, deploying those different components, whether it's operating system, whether it's application, whether it's a driver, whether it's firmware. All those things can use this exact same paradigm to be deployed and to be used. Next slide. The other important thing is, and also kind of touched on in the last discussion, was this idea of what are the drivers in the space industry and the commercialization of the space industry. And that is partly, and actually skip the slide.
Did I?
Yeah. Or did we change the order of the slides?
I guess it did.
Double click. All right.
Still pick up.
We talked about the drivers around the commercial space industry, and essentially they need to drive down costs. They need to develop the commercial space industry is developed more complex ecosystem, these single system kind of build and deploy and fly kind of missions. And we're seeing an emergence of this commercial space industry, hundreds of different providers. And importantly, they're providing, instead of large scale integration services, they're starting to componentize, specialize into different parts of the overall system. And of course, for validation, that's actually a hard problem. We talked yesterday and we heard a little bit about systemic risks that arise as a result of the complexity of our systems and the difficulty of verifying that. Part of that is because as you're combining these different pieces, the combinatorial complexity of all the possible interactions, the tracking of all the metadata and the tests and all the requirements, and the potential interference that those can have. The nice thing about containers, again, it's a packaging format. And again, it's the critical part is we can attest to that and keep the metadata associated with that packaging format and cryptographically attest to it. So as we say test or validate these components, we can attach that metadata, and it doesn't have to be directly like included in that container. It can be attached via signature or via some other cryptographic process. And that can allow us to prove and validate that throughout our supply. And facilitate composition of these. So whether you're that kind of end integrator or component supplier or some provider in between, or the payload or mission specialist, you can use that same kind of process as long as you're using these containerized packages to provide that complete chain of trust and complete attestation chain for all of these. Next slide. You'll notice in that last one as well, you know, we had a kind of block in there for your CI/CD. And I'm going to use that as kind of the generic catch-all for the test and verification and validation processes that we want to be able to perform. Again, that's part of the software development lifecycle. And we can kind of put arbitrary pieces and parts from there. Our goal with using these containerized tools is to automate the process of doing that. So we don't have to do it manually. We have reliability and assurance that these different processes are occurring. And again, generating the appropriate metadata packaged in with that and attached to cryptographically or through an attestation to the associated container and software that we're developing. Now, when we're talking about things like operating systems, the advantage there is, of course, the operating system might have, for example, firmware or drivers or BSPs attached to that as well, through firmware and through other packages, either part of that supply chain provided through the board or directly through the operating system. And we can do that through the exact same process. And this was kind of just to illustrate too, we can get kind of arbitrary complexity with respect to how we compose that CI/CD for these individual pieces and parts. For our operating system, we can introduce things like static analysis, dynamic analysis. I think I heard a little discussion already about SBOMs or SPDX, so metadata. We can verify the components through those that metadata that we either absorb through a supply chain or generate those artifacts so that they can be consumed by another provider or another integrator. And then we can provide things like extra security checks, patches, updates, things like that during this process. And again, the reproducibility of the containers and the CI/CD allows us to repeat that process as often as we want without disrupting that supply chain. Next slide. And the goal here is so that we can rapidly account for and adapt to our security or our testing or validation of requirements. One of the things that we are seeing as a result of like the commercial and the explosion of the commercial space industry is And I kind of, during my intro yesterday, talked about how we're looking at understanding what kind of regulatory frameworks that we need to apply to this industry. The adoption of things like Linux into these kind of use cases means that, and I'll say open source generally, means that these formerly bespoke, custom, highly tested systems are now subject to a lot of the cybersecurity threats and risks that the rest of the commercial software or open source industry are now subject to. As a result, we're seeing like the cybersecurity threat profile for these components increase dramatically. And we need to understand that the result of that is going to be the same sorts of cybersecurity policies and tools that we have to use, say, in enterprise environments are now applicable to, and we need to start using that same sort of rigor from a cybersecurity perspective for these components. So being able to understand that this is coming down the pipeline, that the CI/CD tools and the test and validation tools integrated into that pipeline will help us absorb the cybersecurity risks and implement the appropriate security controls, like more rapid patching or updating, especially with respect to, say, cyber, vulnerabilities in our operating systems or applications. These things are going to have to be absorbed into that supply chain much faster, and we're going to have a process for continuously updating these components that are affected. So these tools are going to help us meet these cybersecurity requirements going forward by incorporating those into that CI/CD process, into those artifacts, and then that metadata and that CI/CD process are going to let us rapidly update our stack information. Now, this is all applicable, like I said, to the operating system. I think we have a demo that will show how we're using these container technologies to do that. So, Tony, I think is going to run this demo. This is going to be a live demo. So,
Yeah.
Tony, take it away.
The demos here. Let me find my cursor and get out of this slideshow. There we go. Okay. So first things first, the underlying technologies that we're going to showcase here are all open source technologies. I'm going to demonstrate them as it relates to like Red Hat Enterprise Linux, being the Linux distribution. However, again, they're open source technologies. How you consume them, apply them to various other flavors of Linux, up to you. But they are open source and available for use. So we start with a container file, which historically, you've probably seen a container file used to bundle up some application and its libraries, dependencies, all those kinds of things, and then deploy it on some, traditional Linux operating system. What we're showing here is starting from a base container image that actually includes a kernel. And the open source project that sits behind this is something called bootc. It stands for bootable containers. And in this example, we have a RHEL 9.5 version of a bootable container. We also, in some of our upstream projects like Fedora, there's a Fedora variant of the bootc container. There's a CentOS Stream one as well, in case you want to test with those. But that's what I'm starting from. And then I've seen a ton of examples using bootc where they just do something simple like, DNF install Apache and it started. I didn't think that was exciting enough. So this morning, I actually, 5:30 when I woke up, I was combing through some GitHub issues, specifically one that our colleague Dan Walsh was on. It was a 65 reply issue. I was going through like, how do I embed a container into this bootc image, like an application container, because that's going to be a common use case. It wasn't a very well documented thing in the bootc community. And so I found this issue. I'm combing through it. I'm like, I'm not going to get this working. I might just have to go to the boring demo, but I ended up figuring it out. And so that's what this ended up being. So the second line here, copy. If you're not familiar, Podman has this thing called Quadlets, which allows you to launch containers with systemd. And so this is my Quadlet file that is going to launch an Apache web server with systemd. And then, of course, in the concept of security, I wanted to have a firewall and expose only the specific HTTP port through the firewall once this container is running. And then this is kind of like this last line here is like the magic that I had to do to get the container embedded. bootc calls it something bound containers. Dan, does that ring a bell? The logically bound container. Yeah. So
Logically bound.
Yeah, so this symlink right here, what it does is it reads the image line of that, what's that system D word I just used again? The,
Something down.
whatever, it reads the image line of that file, quadlet file. And then it symlinks it, and that's where when you do your bootc build, it picks up on that and injects that image into the resulting, the resulting build. And some of the build targets can be like ISO file, if you want to install bare metal, a raw disk image, QCal disk image for virtualization, Amazon AMI, various different build targets from the same container file that defines your image, okay? So we have that. I don't like typing Podman build commands, so I just went ahead and wrote a script that did it for me, so I didn't accidentally fat finger something, but just to show it to you, here's what I'm doing. Since it is a rel-based image, obviously to get access to software in the Red Hat repositories, it needs some entitlements, so I'm doing some mapping of entitlement stuff here just to get around that. So let's go ahead and run the build. That should happen relatively quickly because I didn't change anything and I already had it kind of pre-staged.
It takes about 30 seconds.
Maybe a couple minutes on this slow internet. And then from here to build it, there's a tool called bootc image builder, which is distributed as a container, so you can run that via the command line. But I wanted to show, enough command line, switch to the UI and show you some things here. So this tool that I'm showing or application is something called Podman Desktop. It's a freely available open source community application that you can run on your desktops, similar to like Docker Desktop if you ever use that. But it supports extensions like we have an AI extension, and then the one I'm showing here is the bootc extension. And what it allows me to do is look at images that exist on my file system, and I can select one of these images and say, okay, I want to generate an image that I can then deploy from this particular container. So just need to fill out some variables or some fields, tell it to put my QCal there. I'm going to select QCal as the output type if I want to change the resulting file system. And then you can get a little more advanced with things like specifying config files, which I've done here. And this particular config file, and I'll show it to you shortly. All it's doing is injecting a user account. So super secret password. And of course, I'm adding myself to the wheel group so I can sudo. But yeah, that's all that config file is doing. So now that I have all these filled out, if we were using AWS, I can have it automatically push to an S3 bucket or something like that. I'm going to hit build. It does a privileged build, so it's going to prompt me for my credentials here in a second. I'll type those in. This process is going to take maybe 3 to 5 minutes, but I conveniently already have a QCal file that I've generated, so I'll boot that one up and show you what it looks like.
Yeah, while that's doing that, we showed you like the user config, but there's a bunch of other blueprints that let you install packages, services, other kind of components into that resulting image.
Yep.
And they're just there for convenience, right? So you don't have to do that kind of stuff and manipulate the image directly.
Yep. So this will go through and build that resulting QCal file. As I stated, I already built one here. I built it earlier today at looks like 2:03. So just like I told Mr. Epley last night when we were finalizing these slides at like almost midnight, I'm gonna fire a Vert Manager, which Vert Manager I consider to be one of the best open source.
We were arguing whether it's a good UI or not.
So I'm going to import the QCal that I built earlier today. It is a rel 9. I just like doing unknown because then I'll change it. My laptop's got tons of resources, so let's bump those up. And then I wanted to simulate a disconnected use case, right? That's why I embedded that container image. I wanted to show that, hey, you can deploy this and the system doesn't have to be internet connected, all those kinds of things, which is a pretty common use case. So conveniently, I went into libvirt and created a private isolated network that does not have internet access. So I'm going to boot up this image and you're going to see that my container image automatically starts, it's ready to go. So you can think of this as I created an image of rel that it can be deployed anywhere as an appliance, right? And it'll look and feel, behave just like I defined it in that container file. So finish.
And of course, the advantage there kind of alluded to at the beginning is, you have that exact same workflow. And we kind of in the last discussion, or a couple of discussions today, talked about, well, we want it, and this I think came up with CFS, for example. We want the exact same kind of developer and deployment experience. And that's exactly what it's going to give you. Developer builds a container, that exact same build and build process is used your CI/CD tool. It's then built in and used by your production and deployment. So it's highly reproducible, and then artifacts are movable and deployable. I think we had a question.
Yeah, just real quick, I noticed you saw a bootloader splash, probably correct. So bootable containers, that includes the bootloader as well.
Yep.
So keep using the term container. It's not, yeah, it doesn't seem like a container.
So
Containerized technologies like
It's a nice, yeah, I describe it. Yeah. I'm missing something.
So the workflow is you're building the container, right? And then the build tool will essentially convert that to a bootable. Right, so it is the container is defining the specification for that and creating essentially this and scaffolding the artifact
The container they built, they can run it just.
as a container.
Otherwise, you're stapling up, you're stapling a kernel and a bootloader to it and a root.
Right, but if
Exactly.
you run it as a container.
Right,
Yeah.
They've done is they converted it to. You can ask a question.
Oh,
CD that just. came up. So it's been updated. So what do you?
yeah. So before I answer that question, Dan, it's always intimidating when Dan Walsh asks me questions. But just to show here, right, so on that private network that I created, I do have a gateway address, so my VM can talk to the host, which is always useful in case I'm hosting services. However, I think this is Cloudflare's public DNS server. I can't ping it, so it is truly disconnected. And then if I ran the sudo podman ps, and we see that my HTTP container is running embedded in the thing. Now, to get to Dan's question, updating the container image is pretty simple. You just build a new version of it. And then from the command line, we have this.
And again, it's using the same container build tools, like the actual build is podman build or build a.
Yeah, and just like,
Can say build it better.
well, just like with normal containers, it supports the concept of layers. So it'll only update over the wire what's changed. So you end up with a lot smaller delta updates, things like that. But boot C is the CLI that you use to update all these things. So boot C status tells me the container image I was booted off of. There's boot C upgrade, which will check the upstream repository and do that. Dan, I'm not familiar with doing disconnected boot C updates, but I imagine there's a way to.
So basically you would update the image, push it up, say Docker IO or artifact way.io. On the post operating system. Actually, right, by default, it's set up to do a C upgrade. Yeah, just to go out and check it. Okay, registrations. You will then pull down the layers and change from the original image that the operating system built. You can then reboot new operating system. So you say, so it's like an AV.
Yes.
You'll get a new operating system, and you can actually roll back to the previous.
And so does the upgrade happen automatically? So you don't.
By default, by default.
Yeah, it's good.
By default, we turn it on. Almost everybody's gonna turn it on.
Yeah.
Right. But if we don't turn it on, then no one's ever gonna turn
Well, so
And for the disconnected use case, that original boot image.
it. You control when the operating system is pushed. to register. So in other words, you should be going through a CI/CD system, testing it out everywhere else before you push it. Now, if you had 1,000 of these markers out there, they were all set to automatically update. They would all belong to the registry as soon as the image is there, pull it down and reboot into the new operating system.
So how do you guys see this workflow happen? In ideal scenarios, at the edge, right? You don't have. protection. Like it's severely.
Yeah.
You don't have line processing. Are you proposing that in order to get line with compliance, that we're all running VMs at the edge instead of running smaller lightweight containers?
it doesn't have to be a VM. For my demo, I'm using a VM. You can deploy this on physical hardware. However, for those disconnected or disadvantaged networks, what'll happen is it'll you'll try to push the container update, if you will, or the layer update. But you won't be able to use it and update your system until the complete update is there, and you'll be able to verify that by the checksum and all those kinds of things. So you'll know all the bits are there, ready to go. And to Dan's point, right, we support this out of the box, like the AB style updates. So if something did happen, like something got corrupted, maybe you didn't catch it or whatever, you tried rebooting the system, didn't boot cleanly, you can configure it to auto reboot based on, health checks and things like that that you define. And then there was also a use case we had a conversation with somebody about earlier today where maybe there's one gold image that we always want to keep because we know it's right. We can pin updates. So those are always going to be there in case down the line our future updates kind of break something.
Each show can generate a few counts, so it actually can generate an ISO, so you can install. it.
Yeah.
Generate VMware and generate. Basically,
Yeah.
or it's a
Multiple
container.
companies.
Yeah, and the raw image.
Really, broader image, market now. Really want to do something cool, you can go to an existing operating system. You can run a 5-man run, command privilege, that container privilege. Inside of the container, you see install, and it'll replace your running operating system with the operating system.
Okay, exactly.
Swap. We'll be talking about this in the next.
Yeah, we're gonna, Dan's gonna go into more.
You know,
Oh, and some questions for him.
How we doing on time?
flat image trees for U-boot.
We got about like 2 minutes and we got like 8 more slides.
We have support for flat image trees for U-boot,
Dan, do you know if we plan to support flat images for U-boot
flat image trees.
image trees?
It's just a
I don't know.
bundle.
For you, please,
When you get
Is,
For you.
yeah, flat image trees, it's just a bundle that contains everything from the kernel to your, well.
Oh, there's actually, well, yeah, it is not, it's a bootloader concept, but
Linux, bundle formula. Yeah, it's
yeah,
just,
so we're actually supporting something called UKI, Unified Kernel Image, and that's, right now, we're only supporting it for constant computing use cases. But we're gonna extend support for all use cases, but the idea is we will have a package UP executable as a UP application. It's essentially could bypass the bootloader. So we don't even need a bootloader. In fact, the idea is like get rid of that because it's a risk actually. The bootloader gives you the opportunity to twiddle with kernel parameters and twiddle with firmware and all sorts of other fun stuff. It's potential risk from configuration standpoint and security standpoint. So we'll boot directly into that. And the future goal is to package and extend the same tool chain to package that executable.
so in your argument, you'd say it'd be much safer to use the kernel as a sort of second stage bootloader.
Well,
to
not
using-
even the second stage boot, right? We're going straight from the UFI right into the kernel.
Right, I was getting to booting this bootable image format, a bootable container. You would use the kernel using what was it, KX?
Exactly.
KExec, which might not be supported for all platforms. I'm sure it's, no, it is. Not, it's not. Risk by chance.
You gotta run it from Linux.
Yeah, most of the things.
Okay.
There's a lot of fun stuff.
Yeah, they did.
Yeah, but the goal here would basically use the exact same like AV boot process. And you just have a different API image, right? So you'll boot into a different image without even a boot, right? Bootloader. No. Back,
Yeah.
no more boot.
And I guess in closing, one of the things we're very much interested in is, and I think Epley has the question in here somewhere, is trying to figure out what barriers continue to exist or are still out there for why a traditional Linux operating system like a RHEL, CentOS, Ubuntu, whatever, aren't suitable for these types of use cases, right? Why does Yocto still have to become or be the standard that everybody uses? What would it take to create options or flavors, as was discussed yesterday? I think somebody mentioned it for space.
Rhetorical question.
I mean, it's a discussion question. I mean, we want to understand, I mean, this is our goal. To understand that.
Of Yoctos, it allows you to turn name it, Bluetooth on.
Mhm.
And it causes a cross-sectional build change through all the recipes that feature Bluetooth.
Yep.
You can turn on and off things and then bend, an entire set of packages is built with or without that feature.
Yep.
It's a very powerful model.
Yep.
No distro is gonna do that.
Right,
Yeah.
it's more so, I know Yocto lets you. Very,
That's just one feature.
right, you can tweak your packages very specifically, you can create very lightweight packages.
Yep.
You can configure every single element, you might not want every feature, JWC, for example.
Sure.
And it's useful for lightweight scenarios, but in other scenarios where you want to have just one image that's known and tested, that's an area where a traditional distribution would be very strong and would be very attractive.
Well, and, we're right now creating this image from the relevant, right?
Right.
There's nothing to stop you from building a derivative, lighter weight version of that operating system for certain cases, using the same container-oriented workflow for for the rest of them.
Yeah, I'm sure there's nothing stopping you from taking an image and not sure what the process would be but to import it into put in a container.
Counter arguments more than just said, though, we should build a snowflake. For every single operating system, snowflake as
Right.
opposed to operating systems, you've got billions of computers all.
Yeah, that's exactly, so that's the trade space.
Exactly.
Also on the UKI slide, and I don't know if anyone caught it, but one of the bullets was noting that like one of the things we're working on is a way to add different firmware process. So there'll be essentially guest firmware profiles. Now, that doesn't necessarily solve that, the other, the opposite problem is thinning out just drivers and firmware that you might not. Right? It at least gives you the flexibility for customization.
And last thing I'll say real quick before we turn it over to Dan, and I guess you might have a question. I think what I heard, right, like about Yocto, you're able to slim down the deployed software artifact.
Oh, yeah.
And I think some of that is driven by historically these space computers.
It's not just slimming down.
been-
Let's talk offline.
Yeah.
There's a lot more to it. Yeah.
Okay, yeah,
Yeah,
okay, yeah.
Otherwise, we're just gonna take over. So.
Yeah, did you have a question?
No, I just wanted to make sure
Yep.
that we get to the next session.
Yep, yep. Cool.
Yeah, we're a couple minutes over time.
Take a vacation. Thank you.